on this computer and share screen. Specifically, I will be sharing this. All right, so Sudoku. What we have to do for Sudoku is that we've got this 9x9 board that we want to solve. Now, what you want to do is that when you actually do, so, and again, we have these rules about no duplicates and no duplicate numbers in any row, no duplicate numbers in any column, and no duplicate numbers in any 3x3, or what I'll call box. Okay. Now, with regards to doing to how to start this, you'll want to basically make your you'll want to make yourself a board, not a bard. Singing won't help you here. And you'll want to make yourself, you'll basically want to hard code you'll want to hard code your your puzzle in. I do this so little I forget the syntax on how to do this, which is annoying. But essentially it will be, you'll make yourself a 9x9 array. Okay, and you'll pass it in and you'll fill it up however you want. But to begin with, you can just start with a blank and empty board. Okay. So next, what we need to do is that we need to translate our public static Boolean solve method. And the method takes in, we need to take in the board, int board. And then we need to take in our position. Now, our position here in this case, we can represent that by using two separate values. We can use we want to use our int row and our int column for this. By default, what we're going to do is that we're going to assume that we haven't gotten into a solution, and so we need to backtrack, return false. That is our default assumption. Okay. Now with Sudoku, again, what I don't like is when I see a lot of students who have this over here, int row and column, or they don't pass those in and instead they do this for I row is less than 9. There you go. There we go. And then they do for column less than 9. And then they say if board row col equals 0. That's not really that elegant. Unfortunately, because so basically it's saying, hey, let me go ahead and iterate through the next advanced space. And I'm saying, no, sorry, the next blank space. And I'm saying, no, you shouldn't iterate through. You should already know where you are, relatively speaking. Okay. You're going to be moving left to right, and you're always going to want to move to the next square. All right. Now for this, in that case, how do we do that? Well, you're given a row and a column, and now we have to figure, and we're going to use those to establish base cases. And in our base cases, that's also where we're going to handle being out of bounds. Okay. So we don't have to check if we're going to be going out of bounds by adding one to a row or to a column. If we do go out of bounds, this is where we handle it. So first off, we are going across from left to right, which means that this is column that's increasing, right? This is column 0, column 1, column 2. It feels so weird if you're not used to it that the X direction is the column, but columns are vertical, right? So you feel like it should be Y, and also it's in the second position. So it definitely feels like it should be Y, but it more maps to the X position. So again, just don't think of it in terms of X, Y, think of it in terms of row column. You'll be a lot happier. Okay. So what we do here is that we're going to have a base case. If our column is equal to 9, right? So the board is a 9 by 9 board, meaning the valid indexes are from 0 to 8. So if we hit a column, if we hit column is equal to 9, that means we hit the end of a column. Sorry, hit the end of a row. Okay, and if we've hit the end of the row, then for Sudoku, right, it's a grid. Once we're done with one, we need to go on to the next line, go on to the next line, go on to the next row, go to the next row. So if we hit the end of a row, what should we do? Row, go to the next row, row plus plus. We'll handle that here. It's easiest to handle that here. And then column is equal to 0. In other words, go to the beginning of the next row. Sorry, go to the next row and start at the beginning of it. Make sense? So if we go out of bounds on this, that way we can always say, hey, the next position is always going to be column plus 1. Make sense? And now how do we know we've ended? If the row is equal to 9, make sense? If our row is equal to 9, if we've gone out of bounds of our row, so if we've gone through all 9 of the rows and now we're trying to go to the next row because we just incremented it, that means we're out of bounds. So return true because we're done. We finished everything. Now we have a final base case, okay? Now this is the only parts that I find tricky, so I'm not gonna bother writing the for loop where we call the recursion because that's not actually that tricky, believe it or not. So, but here I will do a bit of recursion, which is what if board, row, column is equal to, is not equal to 0? What if it has something in it? Right? What if the space we're on isn't empty? Then we should go to the next space. Make sense? Solve board, row, col plus 1. Go to the next space. For I, and this is all I'll do here. I is equal to 9. If board, if is valid, board, row, column, I, and let me change that range up. It should be through 9, starting at 1. So this is basically, if I can put this, if I have some number I, can I put this number in this row and column? And my suggestion for you, first off, for this one, is we should is with this valid method, you should start out writing it as return true. So you can focus on getting the recursion done. Thus, if the recursion works correctly, if you implement the recursion correctly, you'll get a board of basically all 1s because it's always valid to put a 1 down and we're starting at 1. Make sense? So once we get that, we should start actually honing into what we do. Specifically, there's 3 rules you have to enforce. So, which is, and I'll write them here. Yeah. And one more copy paste. And I'll change their names. Is row valid, is col valid, and is box valid. Okay, there's 3 rules you have to check. And rather than checking them all in one method, this will make the problem solving easier. Return is row valid, board, and is col valid. Gotta love all that autocomplete action going on. And is box valid, and they're all the same length, so they not line up nice and symmetrical. That's always a nice thing to happen. So now we've got these three things. So this is essentially the same as what I wrote before, except I have three things returning true and I have them connected by ands. So then I can basically do and check, hey, there's no, so this is row valid. What this will do is that it will say, given I, it will check to make sure that there's no, that I doesn't already exist in this row. Same check over here. Does this not already exist in the column? And does this already exist in the box? And if it exists, return false. Here we are assuming that it does not exist to begin with. Sorry, that it is allowed to put it in. So this allows us to do our recursion. So we pass this in, we enter things in. I'm going to just simply do yep. And then when you're done, we can just simply print this array this board very easily. Unfortunately, I wish it was as simple in Python as it was in Python, because of course, as everybody knows, if you do this, if you try to print out your array over here. So if we try to print out a 2D array, we get a notifier that it is a bracket I at a memory location. What this is saying is that it is a 2D array of integers at this memory location. So, and arrays dot toString, which is typically how you convert these things to a string in a much more useful fashion. That doesn't help you here either, because as you'll see, an array is just an array. A 2D array is actually just an array of arrays. So in order to do this, what we do is that we say for each row in the board, and you'll be able to use this for your chessboard as well. Print row, arrays to string that row. And now we'll be able to see, hey, we've got an empty board, but we can print it out nicely. So once you call solve on it, that will go ahead and fill everything out. That will fill it up initially all with ones, and then basically 1 through 9, and then it will once you do your row and your column both being valid, it starts getting really interesting. Let me go ahead and dump this in chat for everybody. Control-C. And hopefully it's not too big. No, it's not. There you go. There, went ahead and dumped it in chat. Can also just grab it and let's see. It also works like that. Cool. There's the file itself in chat. Okay. Any other questions about this one? So for this one, you'll always want to be going over, you'll want to be advancing via column +1. That's what your position, that's how we increment our position in this one. Okay. Any other questions with regards to this? So I figured what we can do is that I can is that for anybody who wants to demo things or have questions about their exam, I can split us up into breakout rooms. I'll let us, and I will just simply rotate through them in numerical order. So I'll create probably more than we actually need and let you choose which room you want to go into. Make sense? And then if you don't need to meet with me, then you're free to go. But if you want to meet with me to demo something, you have questions about it, you have questions about your exam or any upcoming assignments, or actually anything at all, feel free to get into one of those breakout rooms. Okay. Let me go ahead and enable screen sharing for everybody. So that will be a thing. And the breakout rooms will be opened. There's going to be 8 of them. Just simply select which one you want to go to.